Todd Danielson here at the Esri User Conference 2025 in San Diego. And right now I'm with Mark Thacker and Ali Diba at DSCE. Why don't you start by introducing yourselves and explain why you're here at the conference this year?
Hi, good morning, Todd. Mark Thacker. So we're a tech consulting company. Been an Esri partner for 20 plus years. I think Ali has attended this conference for probably most of those 20 years. We're locally based up in Orange County, California, and essentially here supporting our customers, presenting to new customers in the water segment. Water and wastewater is really our kind of focus. Utilities on the West Coast that operate in that sector. Essentially, one of the key offerings that we have today was presented in a paper yesterday, all around how you can leverage the new Esri utility network model to essentially provide 3D visualized services for vertical assets, pump stations, lift stations in sewer, treatment plants, that kind of thing. So visualization of data in a 3D model is and Ali will kind of dive into the details of that, but that's one of the offerings that we have that we're kind of presenting today.
Ali, why don't you introduce yourself and provide a little more detail?
Sure. I'm Ali Diba. I'm the founder of DSCE, and my background is in water supply planning, wastewater modeling technology. As Mark said, we've been a business partner of Esri for many, many years, and since the last 5 years, we basically started discovering that Esri is introducing a new technology called utility network, and we dove deeper into this to see what are the capabilities, what can it do for the audience that we serve. And we realized that one of its features is the ability to display the data in 3D format, in a visually very appealing format, whereas in the past, the areas that we wanted to use GIS on, especially plants and treatment processes, it was really impossible to do this. And we realized this opportunity, and we started exploring it, and we've come up with some solutions that take different sources of data, CAD data or GIS 3D data, and present that in a virtual reality format, in a digital twin format, and open the door for not just the group that handles the linear assets in the field, but also the group that handles vertical assets for treatment processes, pumping, tanks and you name it, disinfection facilities, wells, and those kind of things, to be able to really visualize the data in GIS. And our observation is that this is really a breakthrough. And the reason for it is historically the data has been stored in GIS. It's really linear, hydrant valves and meters and so forth, so on. But now you have a central repository where it has all your assets, including your treatment plants and your lift stations and sewer plants and all of those. And this opens the door for being able to offer solutions, especially asset management solutions, that technically speaking uses only one registry of assets rather than multiple sources of data in spreadsheets or in different asset management systems. And for the industry, this is very helpful because I know many clients of ours have an asset management system for plants and an asset management system for linear assets. Now they can have a single asset management system for the entire solution. The 3D also offers lots of different opportunities, visualization, being able to record knowledge of the staff that is about to retire, have that available for the younger generation to come in, be able to really look at the plants without necessarily having to go out, walk in there and identify the assets. You can do it in the office and get ready for your field visualization before you go there. There's no ambiguity, there's no hey, I was at the wrong pump problem, things like that. This is a start. This is not the end. This is a start because ultimately virtual reality added on top of this, you could at one day, not today, but walk into a plant with a virtual reality display and be able to look at a pump and get all the specs displayed on your screen, and be able to look at the operating procedures, be able to look at all the different real-time data that pump is producing. In the last hour, what was the pressure, how much flow went through it, that kind of stuff. So we believe this is the start of a new revolution of offering GIS to the gaming generation that is used to looking at 3D. There are not very many games that are in 2D anymore. So this is really compatible and aligned with new folks that are coming into this business.
Could you describe the process that you went through to get your data kind of into the system, your 2D data? Was it difficult? What were some of the things that you had to do? Was there anything that maybe you learned that you could share from someone who's maybe considering trying this process?
Yeah, so there are different ways that you can capture reality. So if you just look up reality capture, you will see all the different methods. We used two methods in our experiments. One of them was to fly a drone over a facility that was already built and it was operational, and that gave us the 3D imagery that we needed, the 3D concept that we needed, and then we superimposed the utility network. But prior to doing that, we had to add elevation to the utility network, because without elevation, it really doesn't make sense. So we superimposed that on top of the drone capture, and we made up a scene that has a combination of these, that you can turn it off and on, or select a pipe, or select a valve. This was one approach. And this approach was very successful, but it does require some time that you have to spend on symbolizing in 3D the utility network. There is no such thing available at the moment called 3D symbology of pumps and valves, but that was something that we had to do. The other approach that we did was we ran a LiDAR scan of a pump station that was housed inside the building. And the LiDAR scan was a cart that they ran across the facility, as well as imagery that they took with cameras. And also they had cameras on a long pole that they had to lift up so that they can look at the top of the pump stations and things like that. And that was the second approach. That approach was more CAD oriented, so we ended up with BIM data out of the system. And then we took the BIM data and brought it over to ArcGIS Pro Esri technology, converted it over to a scene, and displayed it over in a 3D format to the client. Both approaches are really appropriate. One makes sense in other areas. There is a third approach that we haven't done yet, and the third approach is, if you are building new facilities today, you should really make sure that you get the BIM data from your engineers and the designers right off the bat. So don't wait until the facility is in place and then try to run a scan. The advantage of that is that if you're building it, you can also get the underground piping figured out from the BIM data that the designer is giving you. Whereas in the other two approaches, there is no underground. We can't see underground. We're running a drone on top, or we're running a scanner. So we had to go back to the as-built drawings to figure out how the piping under the ground is. So if a pipe is going down, where is it going? Is it bending in a 90-degree angle going to another facility? That was one of the lessons learned. You mentioned about other lessons potentially in here. One of the things that I have observed based on my experience is the audience of these environments, the linear versus vertical, they're a completely different audience in the business. There are those that manage plants, and there are those that go out there to the pipes and hydrants and valves and all that. And one audience historically has been made GIS aware, because they use maps in the field to figure out where the lines are. They don't use necessarily maps in the treatment plant to figure out where the lines are, because it's in front of them. So this audience is not necessarily a GIS, super intelligent GIS group. They are really operators that they look at assets, specific assets. So one of the lessons that we learned was that we need to create two separate environments. One that is really GIS centric, which is fine for utility network, but another one that is much, much easier to understand, and it is really focused on vertical. and they don't need to necessarily know all the GIS functionalities of zooming in, zooming out, panning, and all that kind of stuff. They can simply pick, and it will show up. It will show up in 2D and 3D, and then they can from there pick the asset and initiate a work order or do whatever it is that they want to do. So recognition of the audience is a key.
To provide a little more delineation of the new system, what was the old system like, and how did you go about doing the things that you can now do, and what were some of the more difficult items that you have improved upon on the new system?
So one of the most important things is that now the data underneath is in the same database. So single database of asset registry. This is appealing to me as a software person, but not necessarily very appealing to the end user because they don't care. So what they care about now that they didn't have before is a 3D visualization of the plant facility. They didn't have that in the system. If they had it, it was just a CAD drawing, or it was a CAD or a BIM file that they viewed. But it wasn't tied to the asset management solution. It wasn't tied to the GIS. I'll give you an example. If you take a pump out of service in a pump station facility, vertical facility, in the past, you had to go open up the maps to see what lines this pump was feeding water to, and therefore those lines are impacted because you're taking the pump offline. With the tools that we have built for them, they can start to trace from within a treatment facility and find out who the customers are that are going to be impacted, which pressure zone is impacted, and trace this, taking the pump offline out of the treatment facility into the distribution system. So it really brings two pieces together.
I think the specific details are helping a lot. In your presentation, do you have any specific plans that you're describing, or are you kind of describing the overall effectiveness of the new tools?
We actually have 3-4 specific plans that we ran the different modes of reality capture, and we have those in a full system, and we are demonstrating it to the audience there.
Could you do it in a bit of an audio form of what that would look like, since we're doing an audio interview?
Yeah, imagine the ability that you can zoom into an area in the map if you want to, or just use a bookmark, and the bookmark takes you to the facility. You look at a 2D map, a little ugly because in a plant so many things are on top of one another. When you look at it in 2D, you don't really appreciate what's going on there. But imagine there's a button that you can press and view that in 3D now. So now you can view it in 3D, you can rotate the image, and imagine you're in a gaming environment with a plant, water system plant. And as you walk around, you can visualize how the pipes are connected, what are the tank sizes and all that, and you can select any one of those features, click on it, and it will select the valve, or select the line, or select the tank, or select the motor. And now, going back to engineering and operation side of this, now that you've selected this, you can look at the history of maintenance on this, or you can create a maintenance work order, which is what we show in the demonstration. And this is a hub for lots of different things. As you select this, you can also press a button and look at the SCADA data historically for this pump. So it gives you that information right off the bat. There is no ambiguity or question of which pump you selected. So you don't need to navigate a bunch of different tables and structures in order to get to that pump. You visually see which the pump is, click on it and you're there, done. And I don't need to necessarily give you a prescription of how to get to that pump in a linear system, a tabular system that has no notion of 3D.
And so would you find that those are some of the most effective uses of the new technology? It's identifying individual assets and the consequences?
Absolutely. When a supervisor is describing a problem to one of his crew, it's much, much easier to describe that in a 3D environment and point to them and say, hey, this joint is leaking. You need to go and figure out what we need to do, repair it and all that. Than to come in and try to look inside the asset management solution that has thousands and thousands of assets and find your way navigating a hierarchy to that location and then pick that and say, okay, this is the one. the best you could do is you have a photo of this so that you can show the photo and share it with your. But now you don't need necessarily a photo. You could have photos attached to this 3D environment if you want to, but you can really look at it in 3D.
You talked about how you could quickly see the effects of like replacing a pump would be on the downline. Does it also make it a lot easier to reverse engineer up like a problem downline and to try and figure out what the cause is?
Absolutely. If you get customers calling you and telling you that there's not enough pressure on their line, and it doesn't make sense because you know that line should have been pressurized up into certain psi. Well, you can trace that line back to the plant and see which pump is the one that is pushing water into that line, and maybe that pump has a problem that you didn't know about.
Okay, so this is a utility network model. I know utilities are, by definition, relatively large. Does it matter the utility size? Can this be used across your very large utilities or to your as small as they get?
This is completely scalable. So anyone with the major utility sizes can use it, or people that have smaller utilities. We have one client that has over 20 different water systems. These are totally different areas. They're not connected to each other. They're different locations and municipalities and cities and things like that. And they're using it for every one of their facilities. And we have smaller clients that have like 15,000 connections, and they're using it as well. So it's completely scalable and applies to water systems that are disconnected or completely connected.
So you're saying that even larger water utilities aren't necessarily as connected? I would have pictured that they would have been doing this for a while now, and then the smaller utilities need to pick it up, but it's not the case?
No, both. This is applicable technology, and the movement has started, and both small and larger utilities are starting to move to utility network, and as they get there, the option opens up for them to look at things in 3D.
Why the slow uptake? Was it financial, or was they just not aware of what could be done?
Just generally speaking, the water industry loves settling tanks. Mm-hmm. And as they settle at the bottom of the tank, they keep on going until one or two agencies start moving near them. And as those move, then the rest of everybody starts getting mobilized. And also they come to the UC and they get the message from Esri. But sometimes it takes a while, it takes 2 years, 3 years for them to get it. And I think that has happened already.
Okay, I think we found in our business that the engineers mostly just listen to themselves and other engineers. Is there a way that, though, because this is important and it create better outcomes, how are you helping to nudge them along?
Okay, so first of all, you need to really establish a beachhead. And the beachhead is an agency near them that has gone in this direction. And as you said exactly, which is engineers listen to engineers, then you really guide the group that needs to move to contact the group that has moved or is in the middle of the movement. And you bring these guys together, and that's how the momentum gets picked up, and then they start moving forward.
I really like that metaphor of the beachhead. Pick something local that's relevant to you, and
yes,
and start there, and spread it around. I think that'll be some really good advice. Sorry, any other specific details that those not in the utility space? I guess we should just stick with them since you guys are the experts. That they might need to think about before they jump into this, so that they're not trying to figure this all out on the fly. Some things to go into, like pre-planning, if they're going to try and make such of a move.
That's a very good question, and my answer to you is when we do these projects of virtual reality and digital twin, we call them projects, but they're really not projects, they're programs. The reason is because you replace a pump today, you install an additional pump in a pump station, you maybe add another facility, you add a valve, or you add a treatment process, and these processes are changing all the time. So whatever you created 2 years ago with virtual reality for a plant may not be really applicable anymore because the digital twin is out of date. So you need to really think about programs. These are programs that you need to have funding for them year after year to have a process whereby you go update your data and you go update your visualization and update your, and it is very important to consider these in that vision rather than, okay, we're going to go hire a consultant, he's going to do it, and that's the end of the story, goodbye guys. 2 years later, you're looking at pictures that are no longer completely valid.
So as consultants, I figure you're still constantly still learning something new as these go on. What are you taking away from these processes that you think you can pass along to new clients? What's some things that you've learned on this journey?
We are not necessarily at the genesis stage of this. We are somewhere past the genesis. We have tools that you can use and visualize. But as time goes on, and even at the UC conference, there were new tools introduced for viewing 3D data. So we see that as just a technology coming in to aid what we are trying to do here. And we just saw on Monday 2 new technologies that can help you. One was the VR that we were looking at in the plenary, and the other one was the introduction of a new viewer that conceptually could be used in this platform. I see more and more tools to come into play. And I see the technology really is moving in that direction. And ultimately, it's not just the excitement of seeing things in 3D, it's the excitement of seeing and being able to act on them in 3D.
Okay, I think it's great. I think you covered a lot of great topics our audience learned a lot. Is there anything that you felt that we missed that you'd like to cover, or perhaps even a summary?
Not really. I think I described all the different aspects of what we do and how people get motivated. But when during the conference you have representatives from GIS and other areas, and they see these, that is that beachhead effect, which is some entity, agency that has done it gets up and describes this to them, and others are taking note. So I just see this taking off more and more. We are at the rising limb of this technology, and I see within maybe 4 or 5 years, the next generation of this is going to be essentially walking into a room and being able to tell all the facilities around you in detail and drill down into visually, click here on your goggles maybe, and you drill down and take a look at everything that is going on there. So that is, in my mind, what is really happening to asset management industry, if you may.
Perfect. Thank you. I'd stop now.